We've been talking about greatest common factors, looking for greatest common factors of each of these polynomials. What do we find for the greatest common factor of our first 2x polynomial? Dylan, how do you know it's 2x?
Because both x and 2
If you look at the coefficients, both 8 and 2 are divisible by 2. They both have a GCF of 2. Both of these terms have an x in them, so you can take out an x. Good. So 2x. What about your GCF of your second polynomial? Whitney?
3x.
How'd you come up with 3x?
3 and there's an x.
Good. So 3, 9, and 12 are all divisible by 3. They all have a GCF of 3. They also, each of these terms have an x in them, so you can pull out an x as well. So 3x. Very good. Very good. Any questions over finding a GCF from a polynomial? All right. So now that we're able to figure out what this common link is among all of these terms, now we're going to talk about how can we pull it out? How can we take it out of the problem? We're calling this factoring. So with factoring, it's sort of like multiplication in reverse. We're looking at what are the two things that are multiplied together first, or sort of like backwards distributing, pulling it out of each of the problems so it looks like it's ready to distribute. So the first thing with factoring is determining what is that GCF with my polynomial. So looking at this problem, what GCF do I have?
X.
4.
Don't worry about the exponents. That's not really important. Well, the exponent is important with determining how many x's are in each problem. And so if they all had a power of 2 at least, you could take out 2 x's, you could take out an x squared. But we'll talk about that when we get there. But all of these terms are divisible by 4, so it's a GCF of 4. They all have an x in them, so 4x is our GCF. Now, in order to factor out this 4x, we need to take it out of each of these terms. We're thinking about what number times 4, or what polynomial times 4x gave you this answer. We're trying to figure out what is that original polynomial that we multiplied everything by with 4x. We distributed in to get this solution. So, in order to do this, we're sort of going to think of it as a division problem with each term. So we're going to think if I were to divide 4x to the 5th divided by 4x, what would that give me? 4x to the 5th divided by 4x.
X. 0x to the 5th.
Alright, so 4 and 4,
There's 1x.
that'll cancel out to 1. X to the 4, or x to the 5th divided by x, what would that give me?
X, yeah.
So if we remember, dividing by exponents, when I divide by the same term, I subtract my exponents. So x to the 5th divided by x to the 1 will give me x to the 4th. My coefficients cancel out because 4 divided by 4 is 1, and so I just have x to the 4th. Now I have to think about that again. I have to do 24x to the 3rd divided by x to, or 4x. So what's 24 divided by 4? 6. Because it's a negative 24, I didn't say that. We need to remember that this is also going to be a negative. Good. And then x to the 3rd divided by x will give me x to the 2nd, because it's x to the 3rd minus, or divided by x to the 1st, which is just 3 minus 1, 2. And then the last term, 8x divided by 4x. So 8 divided by 4 will give me 2. But what about x to the 1 divided by x to the 1? Well, if we're dividing, we're subtracting. So x to the 1 divided by x to the 1 will be 1 minus 1, which is x to the 0, which is just 1, or it's sort of canceled out. So our x's cancel out, and then 8 divided by 4 is 2. So this is the factored version of that polynomial. We factored out that GCF of each of these terms. We sort of thought about it as the division problem with each piece, and we factored it out. So we factored out the monomial of 4x. And so if you thought about it, if we were to distribute this back in, distribute this back in, just like what we were doing with the double distributing at the very beginning of the day. If we were to distribute this back in, we should get our original polynomial. So if you assume that GCF by x. So this is the factored form. This is sort of your answer of when we try to factor. So we're just sort of looking for what were the two polynomials that were multiplied together to equal what we started with in this case. So you're sort of doing multiplication in reverse. It's like division, but it's not quite the same yet. Are we okay with that for the moment? With how we solve these? Do you want to try another one together? Okay. All right. Looking at this first one. First thing we need to do, find a GCF. 3x. So 9, 15, 12, they're all divisible by 3. So 3, and then we all have an x. So 3x. Good, Dylan. Now, we need to divide each of these terms by 3x to sort of figure out what is that original polynomial that was multiplied by 3x. So 9x to the 6 divided by 3x. So 3, or 9 divided by 3 will give you 3. X to the 6 divided by a single x will give you x to the 5th. We're subtracting those polynomials. We're subtracting those exponents. So that's our first term. 15x to the 4th divided by 3x. So 15 divided by 3 gives me 5. And then x to the 4th divided by a single x. X to the 3rd. I'm going to move this over. And then the last part, 12x divided by 3x. 12 divided by 3 will give me 4. And then x divided by x cancels out. And so 3x to the 5th plus 5x to the 3rd plus 4 was sort of the original after we factor. So these two together, if you want to check your answer, distribute that back together, and we should get our original problem. Let's see. Is this doing okay at the moment?
Yeah.
All right. Take a moment, see if you can do that next one. What can you factor out of each of these problems? What's your GCF and how? So, we said that we're factoring out our GCF of negative 6x squared. If we factor this out, what was our solution? What was the factor that we found?
X squared plus 3x 1 plus 2.
So x squared plus 3x plus 2. We look at each of these terms and divide by that negative 6x squared. We will end up with this. Negative 6x to the 4th. Do negative 6, negative 6 cancel out. X to the 4th divided by x squared just gives you an x to the 2. Negative 18 divided by negative 6 just leaves with a positive 3. So x to the 3rd divided by x squared just gives you an x to the 1. And then negative 12 divided by negative 6 gives you a positive 2. And x squared cancel out, so we're just left with positive 2. So just go for each of those terms. Once you find that GCF and divide each of those terms by that value, then your final solution, you want to write them in parentheses next to each other as if you were to multiply them back in, and that is how we factor. What time? Okay. Okay. I know it looks intimidating.
Oh, wow.
If we think about this though, it looks intimidating. It's the exact same thing. We just have to look for what do they have in common. So looking at A, looking at this first one, looking for that GCF, what do they have in common? What is our GCF for this first problem? Starting with the coefficients. So 2 can go into both of them. Can we get a bigger number though? Can we get a greater? 4 can go into both of them. So 4 is our coefficient. What else do you notice they both have? They both have an x. This one has an x squared. This one has an x. So we can factor in an x in there. What else do they both have? They both have a y as well. So we can say 4xy is your GCF. Colton, pay attention, please. Thank you. So look for that common thing in each of these pieces. What's that common thread? So they both all have a 4. They can both be divisible by 4. They both have an x. They both have a y. Looking for it, we have one y in this one and one x in this one, so we can't go possibly two x's. We can't go two y's. So 1 is going to have to be our lowest value, but we can factor 1 out of each. And then the last step, just like what we did before, we're going to divide each of these by. So 4x squared y. I need to divide that by 4xy. So 4 and 4 are going to cancel out. X squared divided by x will just leave me with one single x. And then y divided by y is going to cancel out as well. So the only thing in this one is just an x. And then we'll go to our second term, do the same thing. 12 divided by 4, well, that will give me a 3. X divided by x, it's going to cancel out. And then y to the 4th divided by y, that will give me a y to the 3rd. And so x plus y, or 3y to the 3rd, would be the other factor after our GCF. So you can still do these even with multiple variables. Just look for that like terms. Cancel them out with that division, and then write them next to each other with that GCF. So take a moment, see if you can try to do that last one. See if you can figure out what are your like terms. Find that big GCF, that multiple term GCF, and then see if you can factor it out. Alright, let's quickly finish this last one. GCF. Looking for a GCF. 9 and 27. 9 and 27 are both divisible by 9. If we look, the lowest number of r's we have in a term is r squared. The lowest number of p's we have in a term is p to the 3rd. So we know both these terms have at least an r squared and at least a p to the 3rd in them. So 9r squared is p to the 3rd. That's our GCF. We're factoring that out. Our first one, 9's cancel out. R to the 4th and r squared will give you just an r squared. P to the 5th and p to the 3rd is just going to give you a p squared. Subtracting the second one, or dividing the second one. 27 divided by 9 gives you a -3. R squared divided by r squared cancels out. P to the 3rd divided by p to the 3rd cancels out. So we're just left with r squared and p squared minus 3 as your factor. So once again, look for those GCFs. And once you find the GCF, pull it from each term and then write them on the outside in those parentheses. Ashton, what's your question? Alright, don't worry about it. Alright. We're going to continue practicing this whenever we meet next. Most likely your assessment will be not Friday. We'll see where we get through it.